Additive Manufacturing, DMLS technology. At the end of this lesson, you will be able to explain the working principle of DMLS technology, list the applications of DMLS technology, list the advantages of DMLS technology, introduction to DMLS technology. Let us take the scenario of smartphone manufacturers. To sustain in the market, they must launch at least 2 variants for each model twice a year. Leaving aside the variant count, manufacturers must produce several units for each in short span of time. Imagine that the company follows traditional manufacturing, which focuses on producing a certain set number of products each period and holding a reserve in case of unexpected demand or shortages. This is because they were codified over 40 years ago, and these theories have not adapted to meet modern demands. To solve this problem, the company follows additive manufacturing techniques as its replacement. It is defined as the process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. It has better potential to redefine product manufacturing completely in 3 dimensions. Types of additive manufacturing processes are powder bed fusion, vat photopolymerization, binder jetting, material extrusion, directed energy deposition, material jetting, and sheet lamination. Today, we will see the direct metal laser sintering process that comes under powder bed fusion. DMLS finds application in manufacturing sector to produce end-use products, especially in niche markets. It is also used for broad prototyping use in the desired material without sacrificing any of the properties. DMLS is being used to produce conformal cooling inserts, direct metal laser sintering. Let's start with the definition of DMLS. DMLS, that is, direct metal laser sintering, is the manufacturing process which creates parts additively by sintering fine metal powder particles, also fusing them together locally. Powder that is applied as a thin layer is deposited onto the build platform or by the powder bed. Size of the metal powders used in this process comes around 20 microns, excluding binder and fluxing agent. Let us see how it is applied in each case. In powder deposition method, the metal powder is contained in a hopper that melts the powder and deposits a thin layer onto the build platform. In the powder bed method, metal powder from the dispenser is applied on the build platform. Laser beam device located on top of the powder bed passes the beam that sinters the powder according to 3D profile. After the first pass, build platform moves down to some distance and the roller once again applies a new layer of powder. Deposition rate of the part depends on the laser spot size, scan speed, number, and complexity of parts. The process will be repeated until the desired part is created. Once it's finished, the metal part needs to cool down before being extracted. If the metal part needs supports, these supports will then be removed manually. Resulting parts have same mechanical behavior of those obtained through conventional techniques. Parts made by this method have material layer thickness ranging from 20 to 100 microns. Dimensional accuracy of the final part is as high as plus or minus 0.5 millimeters. In addition, surface roughness of the part ranges between 14 and 16 micrometers. Materials such as aluminium alloys, stainless steel, maraging steel, and titanium alloy are suitable for part production using the DMLS technology. Next, we will see some advantages of DMLS. This method helps in rapid manufacturing of complex geometries. DMLS provides higher quality 3D print with a higher density. Parts can be manufactured at high speed without any special tooling. With high accuracy, functional pieces can be produced at less cost than traditional manufacturing. Conclusion. Thus, we can conclude that to sustain the growth of any manufacturing company, additive manufacturing is the best solution to utilize the raw materials effectively instead of following traditional manufacturing processes. Summary. In this lesson, you have learnt that DMLS, that is, direct metal laser sintering, is the manufacturing process which creates parts additively by sintering fine metal powder particles, also fusing them together locally. Powder that applied as a thin layer is deposited onto the build platform or by the powder bed. In the powder bed method, deposition rate of the part depends on the laser spot size, scan speed, number, and complexity of parts. This method helps in rapid manufacturing of complex geometries.